Hello friends, in this video today we're going to discuss about Bessel's equations and Bessel function. Okay, these topics are very important for BSc students or if you want to appear CSIR net examination, okay, after MSc. So this topic is very important. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta. And so now let's start. So Bessel's equation, okay. So this differential equation that you can see here, I'm writing here. This is the differential equation, which is called Bessel's equation. This is suppose equation number 1. This differential equation is called Bessel's equation of order n, okay, of order n, right? Now, so before we solve this equation, I would like to suggest, please watch the videos where I have taught how to use Frobenius method to solve differential equation. I have given a link in the description box, link of a playlist of Frobenius method. Please first learn that method, okay? So how to use that method, right? That's very important. So here, to solve this equation, we have to assume the solution, let the solution be y is equal to, just give me a second, let the solution be y is equal to, this is a series solution from r is equal to 0 to infinity ar, where ar is nothing but a constant, x to the power m plus r. And if you expand this series, putting r is equal to 0, 1, 2, 3, so on, then you're gonna get this series. So here I am assuming a series solution, let it be equation number 2. Now let us differentiate both sides of this equation number 2. If you differentiate both sides, this is the equation number 2, this is the power series solution that we have assumed. Now let us differentiate both sides with respect to x. Let us differentiate both sides with respect to x, okay. So if we differentiate this, then what we're going to have, on the left hand side we have dy by dx, on the other hand, so here you see ar, and power on x to the power power on x is m plus r, so it comes up here, then x to the power m plus r minus 1. So what I have done here, I have just applied this formula ddx of x to the power n, which is nothing but n into x to the power n minus 1, right? So just I have used this formula, okay. So hope you have understood this. So now again, if we differentiate this result, again with respect to x, then what we're gonna have, we're gonna get second order derivative of y with respect to x. Then again we're gonna apply this formula, right? And doing so, what we have got ar m plus r. Now the power on x is this time m plus r minus 1, so this must be written first, m plus r minus 1, then x to the power, the power on x will be reduced by one more, so that is m plus r minus 2 now, okay. So hope you have understood this. Here it is m plus r minus 1, then if you reduce it by 1, then it's going to be minus 2, right? So hope you have understood this. Now we're going to use these three results. Here we're going to use these three results. What are the results? Y equal to this, and dy by dx is equal to dx, and second order derivative of y with respect to x is this. We're going to use these three results, this one, and this one, in equation number 1. In this equation we're going to replace this term by this result, okay, and we're going to replace this term here, you can see this term, by this result, right? By this result we're going to replace this term, right? Then we're going to replace this y by this value of y, okay. So let me take a new slide so that I can explain these things, okay. So now let me go to new slide and let me write this results and the equation number 1 on the next slide, new slide. So this was the equation number 1. Let me write here. This one was the equation number 1. Okay, and the results we have got, this one was assumed by me. This was the power series solution, and we have got dy by dx is equal to this. Okay, we have got dy by dx is equal to this, and second order derivative of y with respect to x is this. That's what we have got, right? Now you see, in equation number 1, in this equation, what I have done, I have replaced this by this result. Okay, so hope you have understood this. Then replace this term by this result and replace this y by this result. And if we do so, then what we're going to have, this equation 1 implies this. So that's what we have got, right? Hope you have understood this, what I have done. Okay, now here you see, so I'm not going to write this r is equal to 0 to infinity every time in each and every term. Okay, so it is not necessary. So you have already mentioned once, so don't waste time writing this in each and every term. Okay, so now let me clean this part so that I can simplify this equation further. Okay, so now let me clean it up. Okay, so now here you see, so what I'm going to do here, let me check what are the terms that can be taken common, right? First let me do one thing, x to the power 2 and x to the power this, let's multiply. Then what you're going to have, x to the power m plus r minus 2 plus 2, that's going to be x to the power m plus r, right? Similarly multiply this x with this, then you're going to get the same thing, right? And let me open this bracket as well. If we multiply this with this term, then you're going to get x to the power m plus r plus 2, right? Hope you have understood this. So now let me write what we're going to have after this simplification. So now let me write here, first what we're going to have here. Okay, this term. Okay, so from here you see, if you multiply this 2, then you're gonna get this, right? So this plus 2 minus 2 will be cancel each other, right? Similarly, if we multiply this one and this one, then what we're gonna have, then also we're gonna have this. Let me write here, just give me a second. Okay, then this is what we're gonna have. Okay, right? So this is x to the power 1 and this is x to the power m plus r minus 1. So on multiplication we have got this, right? Now let me open this bracket. Then what we're gonna have, plus x square into this, so that's gonna be equal to, let me write, that's gonna be equal to this here, x here plus 2, we're gonna get x to the power m plus r plus 2, right? Then minus n square into this, then minus n square summation ar x to the power m plus r, that's what we have, equal to 0. Now here you see, this summation ar x to the power m plus r, this is summation ar x to the power m plus r, here summation ar x to the power m plus r. So from these terms, from the first term, from the second term, and from the last term, we can take common, this common, that summation ar, and we can take x to the power m plus r common. Then within bracket, what we're gonna have, this first, let me write this one. Okay, then what we're gonna have, summation, okay, then we're gonna have m plus r plus m plus r, and also minus n square, that's what we're gonna have after taking these two terms common. So hope you have understood this. Let me explain again, just give me a second, let me clean this first. Okay, so now you see, okay, just to give me a second. Okay, done. So now you see, so what we have done this we have taken this part common from this term and from this term as well, and from this term as well. So on taking common, on taking common these two, what we have got from the first term, we have got this, which is written here. From the next term we have got this, which is written here. Then from the last term we have got minus n square, which is written here, right? And the term from where we have taken nothing common, this is this one. So let me write this one here, plus, let me just copy and paste. Okay, so here is the term is equal to 0, right? So hope you have understood this. So now here you see, if you multiply these two, then what you're gonna have here, you see, so this one into m plus r, that's gonna give you m plus r whole square. Then m plus r into minus 1, that's gonna give you minus m plus r. Okay, then we have here plus m plus r, then minus n square. So these two term will cancel each other, right? So then what we're gonna have, then we're gonna have summation ar, and within bracket we're gonna have m plus r whole square minus n square, right? X to the power m plus r, x to the power m plus r, plus summation ar x to the power m plus r plus 2. That's what we're gonna have, right? Hope you have understood this. This is equal to 0. So now let me clean this part. Okay, so now what we can do here, you see, now let me copy this last step and let me go to the next slide. Okay, so here is the last step we have gone. This was the last step, right? So let me write that first. Okay, now here you see that let us equate the coefficient of x to the power m, equating, so let me use the reading here, equating the coefficient of x to the power m to 0. So how to equate that? Let us put r is equal to 0, putting r is equal to 0. Okay, so if you put r is equal to 0 here, okay, then it becomes x to the power m. Okay, right? So then what we can have, so a naught m plus 0 whole square, that means you can write simply m square, right? M square minus n square is equal to 0. This is the coefficient of x to the power m, right? So when you put here r is equal to 0, it becomes x to the power m, and this part is the coefficient of x to the power m, right? And here you see a cannot be equal to 0, because here we have considered that this term is the lowest degree term exists in this solution. Let me write the solution that we have considered. Sorry, here you see this was the solution, right? So if this term exists, then a naught cannot be equal to 0, right? Suppose you have a series, suppose a naught x to the power m plus a 2 something x to the power 2, a 3 x to the power 3, okay, and so on considered. Now you see, if this term here x to the power m, or let it be x to the power 1, okay, so if this term doesn't exist, then this x square will be the lowest degree term, okay, and if it does exist, then its coefficient cannot be equal to 0, okay. So we have considered this is the lowest degree term exists, okay. So if it exists, then we cannot say a naught is equal to 0, right? So suppose you have a series like, suppose x square, x to the power 5, x to the power 6. Suppose here you see we have no x cube, here x to the power 4. That means here these terms are missing, means the coefficient of x to the power 3 is 0, right? So now here we have considered this term exist, okay, which is the term which exists in this solution, which is the lowest degree term exists in this solution, right? So let me consider that way. So here a naught is not equal to 0, a naught is not equal to 0 here, so therefore we can write that m square minus n square is equal to 0, and that implies m is equal to plus minus n, right? We will get this, okay? Now what we're going to do, we're going to equate this, now equating the coefficient of x to the power n plus 1, x to the power m plus 1 to 0 to 0. So to equate the x to the power m plus 1, we need to put r is equal to 1, okay? So here we're going to put r is equal to 1. If we do so, then what we're going to have here, we will get m plus 1 whole square, right? So that's why a1, this r is now 1, okay? a1 m plus 1 whole square, m plus 1 whole square minus n square is equal to 0. Now here you see, as we have got m is equal to n, so that's why m plus 1 must be greater than n. So if you subtract m plus 1 whole square minus n square, then it's never gonna be equal to 0, as we have got this two equal. So m plus 1 must be greater than n, so that's why if you subtract these two, then never going to be equal to 0. So here only possible thing which can be 0 is a1, okay? Here a1 is equal to 0, here a1 is equal to 0, since m plus 1 whole square minus n square cannot be equal to 0. So a1 is equal to 0, that means that here this x to the power m plus 1 term doesn't exist in this solution of this equation, right? Hope you have understood this. Now, okay, so let me take a new slide, right? Before taking a new slide, let me adjust all these things here on the same slide so that I can explain here, okay? So let me write this, let me rearrange all these things first, okay? So here you see, just give me a second. Since a naught is not equal to 0, so that's why we have got this, and which implies this, right? So let me write those things here, okay? Let me write this one here. Okay, now what we're going to do, we're going to equate the coefficient of x to the power m plus r plus 2 with 0, okay? Now here you see, equating the coefficient of x to the power m plus r plus 2 to 0, okay? So in order to equate that, what we're going to do, let me write this one here, okay? Just so what we're going to do, we're going to replace this r by r plus 2, right? We're going to replace this r by r plus 2, and here you see we're going to keep this one as ar, because here already we have r plus 2 on this x to the power m plus r plus 2, so here nothing going to be changed. But here in the first term, here what we're going to do, we're going to replace this r by r plus 2, right? So hope you have understood this. So now, okay, so if we equate this, then what we're going to have, so here let me mention, in the first term, just wait, of left hand side, of this is suppose equation number 3. Of equation number 3, replace r by r plus 2. Okay, so that's what we have done. Then doing so, what we're gonna have, a r plus 2, and we did in bracket we're gonna have m plus, instead of r we're gonna write r plus 2 now. Okay, so here instead of this r, you can say this equation number 3, instead of this r we're gonna replace we're gonna put here r plus 2, right? So that's what we have got. Then n square, then plus, what is the coefficient of x to the power m plus r plus 2 here? Ar. So here we have ar, right, is equal to 0. So here don't write the x to the power m plus r plus 2. Okay, here we are writing only the coefficients. Okay, hope you have understood this. So now here you see, let me simplify this first. Okay, first let me copy the last step and let me go to the new slide. So here is the last step we have got. This is the last step. Now let me simplify this. So from here what we're gonna have, we're gonna have a r plus 2 is equal to minus ar divided by m plus r plus 2 whole square minus n square. That's what we're gonna have. And remember one more thing, that we had got a1 is equal to 0. Okay, remember this value, because we're gonna need this. Remember this value, a1 is equal to 0. That's very important. Okay, so we're gonna use this value here. Okay, now what we're gonna do, let's put r is equal to 1 2 3. Okay, putting r is equal to 0 0 1 2 3 dot dot dot. What are we going to get? We get, first we are going to put r is equal to 0 here. Okay, if you put r equal to 0, then what we're going to have, a2, then we're going to have a2 minus a0. This r is replaced by 0 now. Okay, so ar will be a0 now. Okay, divided by m plus 0 plus 2 means m plus 2 whole square minus n square. That's what we have got, right? Now you see, okay, if you put r is equal to 1 in this above equation, then what we're gonna have, then you're gonna have a r 1 plus 2, that means a3, that means a3. If you replace this r by 1, okay, if you replace this r by 1 on putting r is equal to 1, then you're gonna have a3 is equal to minus, this r will be replaced by 1 again, a1 divided by m plus r plus 2 means 1 plus 2 here, so that is m plus 3 minus n square. So here you see, now you can understand that why I have written this here. This a1 is equal to 0, so let's put 0 here. On putting a1 is equal to 0, we're gonna get here 0. Okay, so now you see, let me write here, since a1 is equal to 0, right? So now you see, now let's see what we're gonna have if we put r is equal to 2 here. If you put r is equal to 2, then we're gonna have a4, and a4 gonna be equal to minus a r means here, now we are putting r is equal to 2 now, so m plus here 2 plus 2, so that's gonna be m plus 4 whole square minus n square, right, minus n square. That's gonna be equal to, now you see, a2, we have already got the value of a2. Let us put this value here. Okay, so if we put that value here, we have minus sign, there is also minus sign, minus this two gonna be on putting a2 is equal to this minus will be plus, right? Hope you have understood this. So now replace this a2 by this value. Okay, so then what we're gonna have, let me write it. So then we're gonna have plus a naught m plus 2 whole square minus n square into m plus 4 whole square minus n square. That's what we're gonna have, right? Sorry, let me write it properly. Okay, now you see, if you find a5, how to find a5? If you put r is equal to 3, if you put r is equal to 3 here, then here you're gonna have minus, so this putting r is equal to 3 here, you're gonna get minus a3 divided by m plus 5 whole square minus n square. So as you see, a3 we have got already 0, so that's why this is going to be also equal to 0. That means we can say that a1 is equal to a3 is equal to a5 is equal to a6, sorry, not 6, a7, only the odd numbers, is equal to dot 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 dot, all these terms going to be 0. Okay, wherever you see a1, a3, a5, okay, that's going to be equal to 0. Okay, because a7 will be equal to minus a5 by something. a5 already here we have got 0, right? Why a5 equal to 0? Because we have got a5 is equal to minus a3 by something. a3 is already equal to 0 here. Why it is 0? Because we have got a3 is equal to minus a1 by something. a1 is already equal to 0. We have determined that one first, right? So putting those values, we have got this terms are equal to 0, right? Hope you have understood this, what is the logic behind it. So now we have got f2, a4, right? And similarly we will get a6. If you observe the pattern, first let me write this results a2, a4 in the next slide, so that I can write the next term using the pattern. So here you see this was a2, and let me write a4 as well. Okay, this term is a4, this term is a4 is equal to this. So what will be a6 then? a6 will be equal to, let me write it properly, a6 will be equal to, if you see this pattern, a2 we have got negative of this, then a4 it becomes positive, then f6 again it will be negative, a0. So here we have m plus 2 whole square minus n square, then we have got m plus 2 whole square minus n square into m plus 4 whole square minus n square. This time we will get just give me a second, this time we are gonna have, just give me a second, just wait, we're gonna have this. Okay, if you observe the pattern, so here you see denominator will be this into m plus 6 whole to the power 2 minus n square. That's what we're gonna have, right? So here you see the pattern. When we had a2, here we have denominator m plus 2 whole square minus n square. When we have written here a4, then the denominator becomes m plus 2 whole square minus n square into m plus 4 whole square minus n square. So when we're gonna write a6, then with these two we have to multiply this one as well, if you observe the pattern carefully. So here you see, here we had m plus 4, here we must have m plus 6, right? In the next term, now you see this is negative, this is positive, this is negative, again next term gonna be positive, a0 divided by, in the denominator we're gonna have these three factors, as well as with these three we're gonna have one more factor, that's gonna be m plus 8 whole to the power 2 minus n square, right? Hope you have understood this pattern, right? So now let me write this properly, just give me a second, let me clean these things. Okay, now let us use this result in the power series solution that we have assumed. Let me go back to the first slide. Here you see this is the equation number 2. Okay, this was the solution that we have considered. Let me copy this solution and let me write here. So here you see this is the solution, right? So putting the values of the coefficients a1 comma a2 comma a3 comma dot 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 so on in equation number 2, what we're going to have. So let me go to the previous slide. Here you see we have already got that a1 a3 a5 a7, these are 0. So a1, this term will be 0, then a3 next term will be also 0, these terms will be gone, will be 0. Okay, those terms whose coefficients are a1 a3 a7, those will be 0, right? a5. So now we're gonna replace this a2, then next term will be a4, then a6. Okay, then putting those values, what we're gonna have, this series will be equal to let me show you something. First let me cut this. Okay, now if you see this series, okay, let me write here, just give me a second. So here next term will be a, here you see next term will be a3 x to the power m plus 3, then we're gonna have a4 x to the power m plus 4, then we're gonna have a5 x to the power m plus 5, then we're gonna have a6 x to the power m plus 6 plus dot 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 so on, then ar x to the power m plus r, right? That's what we're gonna have. This is the series, right? So here the where we have got a1 a3 a5, those terms are 0, right? So now let us replace a2 a4 a6 and so on by these values of the coefficients we can see here, right? If you do so, then what you're gonna have, let me write this. First let me cut those terms which have become already 0. Let me cut this one. Okay, let me cut this one as well, let me cut this one as well. Okay, and we don't need to write all the terms. Okay, let me write just dot dot dot. Okay, so here now we're gonna replace this a by 2, this, let us replace this a by 2 by this result. Okay, let me copy this. So let me put this one here. So this is a by 2, just give me a second. So we are to replace a2 by this. Okay, now let me replace this a4. Okay, let me replace this a4 by this result. Okay, let me copy this result. So this is a4, right? a4 into x to the power m plus 4, right? Let me write this one here, just give me a second. So here you see this is negative, so here this plus sign will be minus, right? Minus, next term will be positive, then next term will be again negative. So now so next term is, here you see we have plus a6 x to the power m plus 6. So here this a6 will be replaced by this value which is negative, right? So let me replace that. So what we're gonna have, minus a naught by, let me copy this first. Okay, into m plus 6 whole square minus n square and x to the power m plus 6 plus dot 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 so on. That's how we're gonna have. Okay, so now let me copy this final result that we have got in this slide and let me go to the next slide. Okay, so here is a new slide. So here is the last result we have got. Okay, now you see, now here you see let me go to the previous slides. So here I have shown m is equal to plus minus n. Here you see, first let me replace m by plus n, then we're going to replace m by minus n. Okay, So now you see, so here you see 4 m is equal to plus n, m is equal to plus n. So this result can be written this way. Let me write this. Let me copy this result first again. Okay. So here you see, let me replace the m by n because m is equal to n. So let me replace m by n. So wherever you have got m, replace those m by n. Okay, wherever you can see m, let me replace it by n. So here we're gonna get n plus 2, n plus 4, n plus 6, and so on. So hope you have understood this. Okay, so now this result is too big. Again, I have to take a new slide. First let me copy this and let me take a new slide. Okay, so here you see, so now you see what we have got here, right? Okay, first check the denominator. So denominator of this term, let me write the denominator of this term, m plus, not m, I have to replace this m by n. Okay, replace all the m by n. Okay, so here I also forgot to replace that n. Here this must be also n, this must be also n, right? So here you see, okay, so denominator of this term, so let me write here n plus 2 whole square minus n square. Okay, now you see, as I have changed the slide, that's why I have written this same step here. You don't need to repeat the step, same step. Okay, so as I have changed the slide, so I don't want to go back to previous slide again and again. That's why I have written that again. Okay, so now let me simplify this part. So that's going to be equal to, if you see, that's going to be equal to n square 4 n plus 4 minus n square. So n square gone. We have got 4n plus 4. If you take 4 common, then within bracket we're gonna have n plus 1. So that means this denominator can be replaced by this one. Okay, so let me replace it by 4 into n plus 1. Okay, so now let me simplify this too. Now as I have already calculated this, right, this is equal to 4 plus n plus 1. Let me replace it by 4 into n plus 1. Here we have already got. Now let me simplify this part. Now if you simplify this part, then what you will get? If you simplify this part, here you see, let me simplify this part. You don't need to write these things. Okay, so now here you see, here we're gonna have n square plus 8n plus 16 minus n square. Again n square gone. We have got 8n plus 16, that's going to be equal to 8n plus 2, 8 into n plus 2. So let me replace this by 8 into n plus 2, right? So similarly, here you see these two terms can be replaced by 4 into n plus 1 and 8 into n plus 2. Now let me simplify this term. Okay, so first let me clean these things. N plus 6 whole square minus n square, that's going to be equal to n square plus 12 n plus 36 minus n square. So n square gone. Again 12 is taken common. So that's why this can be replaced by this value. Okay, so 12 into n plus 3, right? So hope you have understood this. So this is what we have got. Now let me rearrange these terms. So let me write the 8 first. Okay, so 4 into 8 into that, That's how we let me write this. So now let me rearrange this two. Give me a second. So 4 into 8 into 12, 4 into 8 into 12. Let me write this one here, and this. Okay, so hope you have understood this. There should not be any confusion, I think. Okay, so now what we can do one thing. We can take this common, a naught x to the power n. Here also we have a naught x to the power n plus 2 means x to the power n into x square, right? Similarly here we have x to the power n plus 4 means x to the power n into x to the power 4, right? So we can take x to the power n common from its term, and also a naught as well. So let me write that. After taking common, what we're gonna have, y is equal to a naught x to the power n is taken common, and within bracket we're gonna have 1 minus x square. Because x to the power n is taken common, we're gonna have x square only here, right? X square by 4 into n plus 1 plus x to the power 4 by 4 into 8 into n plus 1 into n plus 2, right? Then minus, sorry, it's supposed to be minus x to the power 6, 4 into 8 into 12 into n plus 1 into n plus 2 into n plus 3 plus dot dot dot, so on. That's how we can write. Okay, now here you see this 4 can be written as, just give me a second. So instead of 4 we can write 2 square, right? And here what we can do, we can write 2 into 2 to the power 4. Okay, 2 into 2 to the power 4, because 4 is 2 into 2 and 8 is 2 to the power 3. So 2 to the power 3 into 2, that's gonna be 2 to the power 4, right? So that's, so hope you have understood these things, very simple things, right? So this can be written as 2 into 2 to the power 4. If you calculate this 2, if you multiply this to 2 into 2 to the power 4, you're going to get 4 into 8, same as 4 into 8. Okay, similarly this part here you see 4 means 2 into 2, 8 means 2 cube, and 12 means 3 into 2 square, right? So from here what we can do, 2 into 2 cube, that's going to be 2 to the power 4, into 2 to the power 2, that's going to be 2 to the power 6. So here we can write this 4 into 8 into 12, we can write 2 into 3 into 2 to the power 6. Okay, 2 to the power 6. So why I am doing here this kind of thing, so I will explain now. Just give me a second. So if you write this 4 as 2 square, if you write this one as 2 into 2 to the power 4, and if you write this as 2 into 2 to the power 6, then here 2 into 3 into 2 to the power 6, sorry, 2 into 3 into 2 to the power 6. Here you can see this is x to the power 6, so x to the 2 to the power 6. So this is x to the power 4, here 2 to the power 4, x square, 2 square. So we can write, we can simplify this solution in this form, or you can write this in this form, a naught x to the power n within bracket 1 plus, we can write 1 by n plus 1 into x by 2 whole to the power 2, right? Hope you have understood what is the reason behind it. Okay, similarly in this term also, we can write plus 1 by 2 into n plus 1 into n plus 2 x by 2 whole to the power 4, right? Similarly here also what we can do, minus 1 by let me write it properly, 1 by 2 into 3 into n plus 1 n plus 2 into n plus 3 and x by 2 whole to the power 6, x by 2 whole to the power 6, right? So hope you have understood this. Let me rearrange these things to write it properly. Okay, so just give me a second. So here x by 2 to the power 6, right? Okay, then plus dot 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 so on, right? Hope you have understood this. That's how we have got. Now let me clean the above step. So this is what we have done. Okay, now let me copy the last step, then let me take a new slide again. Okay, here is the last step. Okay, so here now this result also can be written in this form also. A naught x to the power n summation r is equal to 0 to infinity minus 1 to the power r 1 by factorial r n plus 1 n plus 2 dot 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 n plus r into x by 2 whole to the power twice r. Let me show you how. So when you put r is equal to 0 here, this to the anything to the power 0 is 1, right? So here also this is gonna be equal to 1. Okay, so here factorial 0 will be again 1. So now you see here we have n plus 1. We can consider this as factorial 1 into this, right? We can consider this one as factorial 2 into this, right? So when for r is equal to 1, you have got this n plus 1. For r is equal to 2, you have got here n plus 1 into n plus 2. For r is equal to 3, so you're gonna have here 2 into 3, which can be written as factorial 3 into n1 plus n plus 1 into n plus 2 into n plus 3, right? So similarly for r is equal to 4, just give me a second. Okay, and for r is equal to 0, we will get 1. Okay, so second term here you see, when you put r is equal to 1, then you have to take n plus 1 and factorial 1 here. Okay, when you put r is equal to 2, then you have to take n plus 1 into n plus 2 here, and it's supposed to be factorial 2, right? And this 2 into 3 is nothing but that's going to be equal to factorial 3, and for r is equal to 3, we have to take n plus 1 into n plus 2 into n plus 3. Similarly, when you will put r is equal to 4, then you have to take 4 terms here, so n plus 1 into n plus 2 into n plus 3 into up to n plus 4. And when r becomes equal to r, then you have to take this up to n plus r. That's it. Similarly, this power here, it can be written as 2 into 1, right? Here this 4 can be written as 2 into 2 when r is equal to 2. When r is equal to 3, it can be written as 2 into 3, right? Which is 6, right? Hope you have understood this. So that's why for r is equal to r, we can write here twice r. Okay, so hope you have understood this. Okay, now let me clean these things. Let this is be suppose equation number. Just give me a second. This is suppose equation number, let me check, equation number 4. Okay, so this is called solution of Bessel's equation. Okay, now you see, if you put before that, let me tell you one more thing. If m is equal to minus n, okay, if m is equal to minus n, then you have to replace this n by minus n. Okay, then you have to replace this. Okay, let me show you here. Just give me a second. Now you see, so for m is equal to minus n, you have to write here minus n. This, instead of n plus 1, you have to write here n minus n plus 1, then minus n plus 2, then minus n plus r. Right, hope you have understood this. So now if you put this a naught is equal to 1 by 2 to the power n gamma of n plus 1, then it will be called Bessel's function. Okay, so let me copy this equation number 4 and let me go to the next slide. Okay, if you put a naught is equal to 1 by 2 to the power n gamma n plus 1, gamma of n plus 1, then this solution is called Bessel's function. Okay, Bessel's function, denoted by Jn of x, right. So now what we're going to do, let me copy this. Okay, so this is nothing but, here you see, just replace this a naught by this value. Okay, replace this a naught by this value. So then what we're gonna have, if you put a naught is equal to this here, then this is known as Bessel's function, right? So hope you have understood this. Now here you see x to the power n, 2 to the power n, so we can write this in this way, x by 2 whole to the power n, x by 2 whole to the power n, then summation this, let me write this one here, just give me a second. Okay, now you see, if you multiply this 1 by gamma of n plus 1 with this, then what you will have, so this part will be gamma of n plus r plus 1. Well, let me explain. Now you see, gamma of n plus 1 is nothing but factorial n, right? Now here you see, gamma of n plus 1, when it is multiplied by this n plus 1 into n plus 2 dot 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 into n plus r. Now gamma of n plus 1 is factorial n, then multiplied by this. Now here you see, this is factorial n, this is n plus 1, n plus 2, then up to n plus r, that's going to be equal to n plus r factorial, right? N plus r factorial. And using this property we can write, if n plus r factorial, if you see gamma of n plus 1 is n factorial, that means n factorial can be written as gamma of n plus 1. So n plus r factorial can be written as gamma of n plus r plus 1. Now you see, this is how we have got this n plus r factorial. Now you see, let me give you an example. Suppose you have factorial 3 into 3 plus 1, that means 4, then 3 plus 2, that means 5, then 3 plus 6, that means 3 plus 2, then 3 plus 3, that means 6. Okay, this is 3 plus 1 into this is 3 plus 2 into this is 3 plus 3. So that's why it can be written as factorial 6, because you see, this is factorial 3 means, this factorial 3 means 3 into 2 into 1, right? 3 into 2 into 1. So 1 into 2 into 3 into 4 into 5 into 6, now it's become factorial 6, right? So hope you have understood this. So similarly, factorial n into factorial n plus n plus 1 into n plus 2 into dot 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 n plus r, that's going to be equal to factorial n plus r, and which can be written gamma of n plus r plus 1 using this property, right? So hope you have understood this. But why we have expressed this in terms of gamma instead of factorial? Because so in Bessel's function, this number, this n, it is not necessary that it will be a integer, okay, but this factorial n is only applicable for integers, okay. So that's why I have used here gamma. So that's why it must express in terms of gamma, okay, gamma of n plus r plus 1, okay, not factorial. So hope you have understood this. Now this is called Bessel's function. This is called Bessel's function. Now if you replace n by minus n of x, then you can just replace this n by minus n. Then what we can have, we can write this in this way. And one more thing, let me tell you one more thing. If you multiply this term with this, then you can write this function in this way. So then here we need to write n plus twice r, right? Hope you have understood this. So this n by x to the power n by 2 to the power n, this is x by 2 whole to the power n. If you multiply this one and this, then you will get this, right? So hope you have understood this. So now you see, if you replace the n by minus n, then here this function, the same function, can be written this way. Just give me a second. Sorry. So we can write this way in terms of minus n. So here replace this n by minus n. Just here let me write minus n, okay. So that's what we will get. That is j minus n of x is equal to this, right? Now combining these two functions, we can write the general solution of the Bessel's equation. That means that equation number 1 that we have I have written in the first page. So let me show you this differential equation number 1. This is Bessel's equation, and solution of this equation can be written as solution of the Bessel's equation is y is equal to a into, which is a constant, j n of x, then plus j minus n of x. Here we need another constant, let it be b, capital B, okay. So combining these two, we're gonna get the general solution of the Bessel's equation, right? So hope you have understood this. Thank you for watching. See you in the next video. In the next video we're gonna discuss some important formula, okay.